Today I will discuss serial communication in 8051 microcontroller. But first we must discuss what communication is. Communication is the transfer of data between two entities, systems or points. Communication may be of two types: parallel, in which multiple bits are transferred simultaneously through multiple channels, and serial communication, which entails single bits being transferred through a single channel. Serial communication is simpler and cheaply implementable at the cost of speed.
There are two transmission modes, asynchronous and synchronous modes. In asynchronous transmission and reception, the transmitter and receiver are connected to different clock sources, albeit same clock should be present. In synchronous mode, the clock is the same, wherein the master generates and sends the clock signal to the slave.
Serial communication is done using various transmission types: simplex, half duplex and full duplex. In a simplex channel, the transmitter and receiver are connected by a unidirectional channel. In a half duplex channel, at one time, a system can either transmit or receive data. Simultaneous transmission and reception, however, is not possible. In a full duplex channel, independent channels for simultaneous transmission and receival are present.
Looking into UART, which is asynchronous, in asynchronous transmission, characters are transmitted one after the other, which undergo framing, in which each character is added with some external bits, the start bit and the stop bits, which indicate the start and stop of characters, helping to synchronize the transmitter and receiver. After transmission of the start bit, the 8-bit character followed by an optional parity bit and a stop bit are shown. The entire collection of transmitted bits is called a frame. Serial communication in the 8051 is provided by the Universal Asynchronous Receiver Transmitter, or the UART. UART is a peripheral used in the controller to provide asynchronous communication. It acts as an interface between the controller and serial port. UART receives data in byte from processor and converts it into serial data and transmits it to the peripheral and converts data from peripheral to byte. UART operates at TTL levels and not RS-232 standard, which represents data at higher voltage levels. RS-232 was designed by Electronics Industries Association with voltage specification -3 to -25 volt for logic 1 and 3 to 25 volt for logic 0. We use 3 pins of the 9 of RS-232 model: the received data, the transmitted data and the signal ground. An IC called MAX232 is used to convert TTL logic to RS-232 protocol and vice versa. The register that are needed to be accessed are the SBUF, or the serial buffer register, in which the data to be transmitted is placed. Any received data is stored in the SBUF as well. For transmission, the data is placed in the SBUF, whereas for receival, data is received in the SBUF, from where it is picked up into other variables. Another register to be accessed is called the SCON, the serial control register, which is bit addressable with each bit as shown. The modes of the SCON are as shown. Mode 0 is 8-bit shift register mode, whereas mode 1 is 8-bit UART mode. Mode 2 and mode 3 are 9-bit UART modes and are used in multiprocessor environment. The SMOD controls the baud rate, that is the number of bits sent per second, including the start and stop bits. The formula for calculating the baud rate is as shown.